Hello, I'm Philip Phantom from Talent Smart, the producers of Technafresh. Our objective with Technafresh is to create a community that's dedicated to exploring and understanding how technology and business can enhance and enable humankind. We want to create an interactive forum driven by the community where people can share ideas, solve problems, and enjoy lively discussion and debate about the future of technology and the future of business. We want to create a library of blogs, podcasts, and events driven by you, the community, and the audience. If you're interested in becoming part of the Technofresh Collective, taking an active part, please reach out to us and let us know. In the meantime, enjoy this session. Ready? And I'll keep an eye on the audience participation if anyone has any trouble logging in. So, well, welcome everyone. Thank you to the panelists. I know Phil Black, you'll introduce those in a moment. Thank you for everyone taking the time to attend. You've probably seen this already, but I just wanted to let you know what Technofresh is all about. So the idea of Technofresh is to create a community where we come together and we can explore and discuss technology, and particularly around the area of how technology can enhance and enable humankind and what it will look like in the future, how it can be a facilitator and how it can be a force for good. And that's really what Technofresh is all about. I'm always looking for people to join the community, to join the sessions. If you're interested in being a contributor, please let us know. Just reach out to me on LinkedIn, reach out to me on my email address, and we'll get the conversation and keep the conversation going. First off, I want to introduce our host. I'm absolutely thrilled he's chosen by means of me twisting his arm to do it once more. He was brilliant last time out. I'm sure he will be even excelled beyond his last time this time. He's the chairman of the advisory board for Altamira.ai, if you want to look them up. He's also the founder of a tech startup in the education space called Cormiris. And again, I know Phil, we'll probably do a feature later on Cormiris and what you're going to do and how you're going to navigate your way through changing the education sector. So I'm really keen to maybe we can explore that in a one-to-one a bit more in an interview and get out there. But without further ado, I'd like to introduce you to Phil Black. Phil, over to you.
Thanks very much, Phil. And welcome to everybody. This is session number 2 of the Technofresh sessions. And I'm really excited for today. I mean, the topic of AI is one that probably gets talked about more than most, maybe on par with cloud, with the people I talk to on a regular basis. And I am delighted with the panel that we have. We have many decades of experience in front of us, not just within AI, but in technology themselves, and a wide variety of backgrounds and applications. So I'm going to just give a quick introduction to start off with, and then we'll get right into a discussion about all things AI. So we got Varun Agarwal. He's the co-founder of Aspiring Minds, which is a very innovative piece of hiring software and a company that Varun was building for many years, all on the back of AI and machine learning and all those sorts of technologies. And he will be able to explain in far better detail the trials and tribulations of building such a company. We have Felix Hovsepian, who is an author and a professor in AI. I think Felix has been around this topic for, I won't say how many years, but quite a few years, very experienced, and has seen a number of explosions of AI bubbles over the time, and some may not have quite met the expectations that were promised. So it's great to have you. And then we have Jonathan Rivers, who is the CTO of Fortune. And Jonathan has got a lot of experience working with different technology firms and in different sectors, and has a huge experience of building technology-based businesses. So welcome all three of you. I'm excited to have the conversation. So as we were preparing for this, we have one-on-one conversations, and just so we all kind of got some good talking points and we can weave it all together. And we will start with some fairly easy ones, and we'll warm up to some maybe more contentious topics a bit later on. And but I love the topic of AI. I remember going to university because of the AI piece of my computer science degree, and I left quite underwhelmed by the AI back in the late 90s, although there was some pretty cool stuff around neural nets and playing chess against computers, which has obviously gone on a long way. And today we have automated vehicles. We've got amazing medical diagnosis. We've got chatbots that kind of deal with many facets of our lives. But there's a lot of confusion around the topic of AI, what it is, what it isn't, will it deliver on the promise, and actually, how do we go about it within the business? So just to start us off, and maybe Felix, if you would give us a little bit of your background, your experiences, and just give us a sense of your thought process when it comes to the topic of AI.
Sure. I started off as a mathematician, and I still am really, and got into, so that's pure maths. I got into applied maths. Been in industry, worked for Fortune 500 companies like Deloitte. But my real passion came round about the early 80s, 81, 82, when I was first introduced into symbolic computation. So that's programs that would deal with symbols as opposed to numerics. From there, I got interested in machine reasoning. And that's been much of my career, has been in sort of complex adaptive systems and machine reasoning. But I hit the second AI winter around about the late 1980s, late 1980s, early 1990s. Got out into industry and really built a career up to a CTO in just classical software and that domain. So it's really been, and I've been an academic for a decade or so.
And today you're actually helping business leaders understand the concepts of AI within their own worlds, right? So you teach a class.
Yes. My goal really was to separate out the hype from reality, because I think there's an awful lot, particularly in the media, which is wishful thinking at best, and we're anthropomorphizing the machines, which I think is a real danger. So helping C-suite executives really understand what are the business applications of AI and how can it be of help to them, rather than thinking of replacing a human being, much like some of the machine people like to think that, radiologists tomorrow will be replaced by software.
Well, I think the reason why I pulled that last piece out is because the conversation with business partners, like setting and managing expectations, is going to be something that I think we're going to have to come back through a couple of times, because it is something that we all have to deal with from time to time. So quick intro, the same for Varun, if you don't mind. Just a bit of your background. I forgot to mention you're also an author as well, which covers the topic of AI. Just give us a bit more of a detail.
Sure. So, I'm an engineer by training. I went to MIT way back to do a PhD program, but dropped out after my master's. And that time I was doing machine learning and optimization, and then built this company, which Phil was talking about, called Aspiring Minds. And that's where we started using, machine learning. That's what we used to call it in those days. And then it started, at some point was called data science, and then some point called AI by the media. But started applying machine learning in our products. I think the first product we built was around in 2012, and then several other products after that using machine learning. And our basic use case at that point of time was doing assessments. I can explain the business case or the use case in 30 seconds. Is that if you look at traditional tests, they are multiple choice question-based tests, where there'll be a question and there'll be a few options, and the person has to choose the correct option. And when you are assessing a person, that takes you only that far. So the AI use case is simply that if you give a person a question and they're replying with an open response, which is text or programs or spoken, a spoken response, how can you automatically evaluate that? And that's what we were using AI for. And one of the jokes which I say, and it just says how AI has evolved in all these years, is that the first couple of people I hired to do AI, they came back to me after 1 year and said that, oh, all of our friends are doing this software stuff and you're making us do this really funny stuff, which no one else is doing. So do we have a career? And I said, you just wait and watch, and we know how it has changed since then. So that's what I've been doing, building AI-led products for in assessment space and now more broadly in the hiring space. And Phil, I'll be happy to talk more about that. And yes, I did recently write a book. It's a fiction. I have it here. It's called The Bird Farm, and it is inspired by the Animal Farm, and it looks at how technology has impacted our society. So when I was thinking about it a few years back, I thought that there was a promise, and that the promise, materialized in a very different way than we thought. And it reminded me back of Animal Farm and a promise being made and realized in a different way. So that's how the book came about.
Well, I hear good things about the book, Varun. So, and
Thank you.
You've got a nice little audience here. So you see the book sales go up and the royalties go up from today. But it's really good. And thinking about the company that you've built and where you're at now, and all of the learnings through that, I think for many technology leaders, understanding what that looks like and the challenges and the trials and tribulations of building machine learning based products will be very helpful. And so you're more of a, we built it from scratch, a native. And now let's introduce Jonathan, who spends a bit more time working with not greenfield sites, the opposite of a greenfield often, and still has to bring some of those ideas together. So would you introduce yourself?
Sure. I'm Jonathan Rivers, CTO of Fortune Media. Most people know it as Fortune Magazine, but I'm on a course to turn us from a stuffy old business magazine to a digital media company, which is, it's an interesting challenge where you really have to start building out capabilities. Where I joined Fortune 2 years ago, where I inherited a 5-year-old website. Now I'm going to repeat that. Their website was this many years old. And that's sort of frightening at how young Fortune was to this game, and have really spent the last 18 months building out a large number of applications, really building out our distribution channels so that we can get our content, so that we have all of the components that we need to be, to be a digital media company. Let alone before we really start innovating and advancing things. And prior to that, I've got about 20 years in media. It's interesting. I probably did what would be now classified as the first sort of AI type build, which is really just machine learning, probably in the mid 2000s at an ad serving company that I was running at the time, where we hired a statistician to come in and analyze advertising banner performance on websites, right? And so this is like 2009. And I literally used Amazon's Mechanical Turk service to have random people classify the picture of a banner, right? This banner has a car on it. This banner is for paint. It is for Pepsi. It is for beer, right? And then the statistician took all of those classified banner IDs and ran it versus performance, building out the statistical models in R to determine what types of banners performed better on what types of sites. Now, that took us 3 months and yielded very, very little interesting to say, because it was so manual and we didn't really have the technology. Sort of Varun could probably attest that his models could probably do all of that with computer vision in a couple of days. What it took us 3 months just to code the banners before he could actually run the models. And so it's interesting thinking about the applied use of the technology now, how it's advanced, and really how democratized the tools are. Because the tools to do all of the software is open source, it's all available, but the actual knowledge of how to do it And then how to actually apply what you've done becomes really, really critical, and what I'm fascinated by these days.
Excellent. And so, like, before we get into a lot of the technical detail, let's just talk a little bit more about the business stakeholder management and the expectation management side of life. So, like the hype that goes alongside AI when you do see, you know, robots dancing and, you know, stories like that, which are all cool and they're great. They're great advancements in robotics and things like that. But so how, Jonathan, do you talk to your business partners? Because you're saying that, you know, they've got a big journey to go on. I'm sure there's a lot of excitement about what the art of the possible is. Some things will be AI, others might just be automation of stuff that can be automated, which computing folks have been doing for many, many years. But how are you managing their expectations and what are you talking to them about?
Yeah, well, I mean, you could tell I talk to them about this topic a lot because I have no hair. I used to have a full head, and then trying to explain AI to the C-suite has caused me to sort of go bald and age prematurely. And so I've given up, quit being pedantic when anytime they talk to me about AI, I go, it's not AI. None of it can reason, right? I've stopped doing that because it's a distraction and really just makes them mad rather than informs them. And instead I lead with, it's not magic. And I think that's the start, because I'll use the term AI just for simplicity's sake for the part of this sort of conversation. AI today is literally no different than any computer program, in that if you tell it what to do, it will go and execute that. And you know, those robots dancing, really great example, because it looks so fantastic. Somebody told it how to dance. Mm-hmm. It told it what to dance to. It told it what dance moves are possible. It's not feeling the music. It's not interpreting the music. There's no actual reasoning there. It's not dancing because it wants to. That robot is dancing because it was told to dance, or it was told to dance when music came on. And that's really where you have to frame a lot of this, where a lot of AI is applying very, very fast reasoning or really fast sets of instruction to certain kinds of data for an outcome. And you're either trying to learn something, you know, by I'm going to expose this to a lot of information and hopefully it's going to look through it and come up with certain insights, or you're going to tell it to do certain things if it sees certain things, right? And again, it's not magic, because and this was the breakthrough that I had in really explaining it, because to apply it in a practical fashion, you have to know what something is, and then you have to tell it what to do when it sees it. There's no judgment call, right? If I put a stack of bills in front of my accounts receivable person, they're going to make judgments about what gets paid when. They're going to have instinct. They're going to know the other things in the business, what the CFO wants. An AI application has to be told to do with what to do with every bill and every permutation, and if not, stop. And so that's really, it can do it really fast. Yeah. And it can do it with a low margin of error, which makes it great for process automation, but you still have to tell it what to do. And if you don't know what things are and you can't tell it what to do, then you shouldn't get started in the first place.
Okay, so that's really good. And Felix, you know, when you're talking with business leaders and people, kind of what are the big questions that they have in their heads, or the big confusions that you're helping them wrestle with?
Well, I think typically I find that they have wonderful imaginations of what this technology has the potential of doing. And that's great. You know, it's wonderful to see that. The difficulty that I face is that maybe we're 100 years away from that kind of technology. You know, we really don't have the underpinnings that we need in order to develop those kinds of solutions. I completely agree with Jonathan. Mm-hmm. And also, I try and ask questions like, does it really matter whether it's AI or anything else? You know, whether it's cloud technology, AI, call it what you like, as long as it produces a valid business result. I mean, surely that's what we're really after, something that gives us a decent ROI. And particularly, you know, I look at things like the healthcare sector or the education sector, and they can get some fantastic ROI simply by just fixing what they have. So I think it's important to take into consideration, what is the problem you're trying to solve? I think, you know, all too often the AI, yeah, it's not AI, but whatever the technology is, they feel that, you know, we don't really understand the problem, so we're just going to throw this software at it and it's going to figure it out for itself. And that's just not true. So trying to explain the capabilities, I think, is really the main hurdle.
So what does that look like, Felix? So like a lot of people that I'm talking to, especially in the entrepreneurial space, you know, every idea now has some form of AI component. I am guilty of this myself.
Yeah.
I can talk about that. But like there is an inherent excitement for people with ideas that going, actually, if I can train it to do this, I can do it much more effectively. So there's kind of an explosion of ideas, all looking for money, all looking for capital. Right. And so what is it just about, well, just understand your idea as much as you can, or is there something else in that conversation that you're having with them?
I think they hear things and they read things in the media. And that is my biggest hurdle in trying to sort of explain to them that it's a wonderful result in the lab. Why don't we just wait for a month or two and see what happens when it gets taken out into the real world?
Yeah.
And I spent probably about 7 years in R&D in a sort of clinical environment, in the sense that it was a pure R&D in academia. And you can write wonderful software and show what amazing capabilities it has.
Yeah. And
Google found this out the hard way when they took out their digital retinopathy out to Thailand, I believe it was. And it, you know, they were claiming 95% accuracy on diagnosing diabetic retinopathy. They took it out into the field and the people just didn't want to use it. You know, and it's explaining to them that, yes, it's great if you have really high resolution, clean images. So your data is wonderfully clean because you have control over all the equipment, how it's taken, everything else. But once you take it out into the field and you have to deal with the fact that they don't even darken the room because it's a school hall that is being used for doing those types of imaging, that they realize that there are critical factors in the real world they've not taken into consideration. So it's kind of trying to align the reality with R&D type solutions.
Yeah, so I mean, that leads us back to kind of product development, creating things that people are going to use, creating things that people might want, solving problems, serving needs. And obviously, I think we all agree that technology should do that generally, as should all products and services. So Varun, now going back to you, you built a company, you co-founded this thing, you probably had to raise money, get investors, at least get some backing to go build it. Like, so how did you go through that process, especially as you started, you know, many years ago before the current hype that exists? What were your approaches to setting expectations and managing that?
Sure. Oh, and you know, what has happened in today's world, as Felix was saying, right, that it has become such a big buzzword, and in fact, it attracts funding and it attracts customers and so on. And when you look under the hood, you know, a lot of companies are not using AI at all, or you know, there's this joke that you just was calling it you're just doing a logistic regression and calling it AI, which is a simple statistical technique, right? So I think for us, when we were raising money, and in that point of time, this hype was, we were in the pre-hype kind of period, and we were in fact, our problem was different. We were educating our customer and investor in what we are doing, and why it is different from what from others are doing, and so on. But I think the biggest piece is that, and Felix alluded to it, is that uh, today a lot of companies have mandates on saying that you use AI. They don't even know what problem they want to solve using AI, but they have this top-down mandate from the board and saying use AI, right? And I've like talked to people who've said, "Oh, we want some help," and then I said, "What help do you want?" And they're saying that we want to use AI, and I'll say, "What problem do you want to solve?" And say, "We don't know what problem we want to solve, but we want to use AI." Right, and that's the generation we are in right now. But I think what is most important is to understand where you will use it and what value it is going to create for customers. And Phil, the question which you were asking was that how do you explain it to business leaders? I think you can explain it in various different ways, and there could be various different metaphors. Like you can say it's what algorithms cannot solve deterministically, it is some heuristic learning and so on. But at least I think what works best is examples, and tell them that what kind of things it can solve. And as was saying, right, uh, AI can do certain things today and it cannot do certain things today. Like when you're talking about setting expectations, for example, if you go speaker independent speech recognition, which is being able to transcribe text from speech for any individual without speaker adaptation. Sorry for being very technical here, but just being able to do speaker recognition was not solved a few years back. It got recently solved. That means that we could not have done we could not have transcribed text for anyone just on the fly. And you need to explain some of these things to the business leaders and the customers, that this is what is possible and this is what is not possible today, and you can build products based on that. Now speaker recognition since then has got solved, so that kind of opens up a new set of opportunities to build newer kinds of products which was probably not possible before. But just going back to the point which I was trying to make, is that you need to create these examples of where in the business it can create business value, and then sift through those examples and say that what is giving you the biggest bang for the buck, right?
Yeah.
Put it on that effort impact kind of matrix and see. And I think that can only happen when you have people who do AI talk with product people and business people. It kind of emerges bottom up. You just cannot business leaders cannot sit in a room and figure out that how they will use AI in their product. So I think the mechanism is that those ideas need to come bottom up, and what business leaders can really then see is sort those ideas and say what creates the biggest bang for the buck, and pursue those ideas.
See, so what I like about that, Varun, is when you're thinking about product development, you've got some ideas, or there's a customer need that you can see, and then you go through an iterative human-centered design process, and that's probably a whole different topic. All of a sudden we've got an extra aspect though, which is how are we going to create the algorithms, how are we going to train the data models, how are we going to do all of that good stuff, as well as create a beautiful interface, create something that users actually want to touch and feel and play with. And so have you got any insights into kind of how that all fits together as a development process?
Sure. And it is something which we are even trying to do today with SHL, the company which acquired Aspiring Minds, and to see that how does AI fit in the whole product development life cycle. And I'll be honest, we are still learning the ropes of how to do it. But the way it has generally worked for us is that we would engage with the product team at the beginning when we are thinking about the idea and trying to scope it and say what it can do and what it cannot do, right? Because AI has its limitations, and we need to make sure that what we are building will actually create customer delight and not make the customer run away because for what it can do and it cannot do.
Yeah.
And what you were saying, there's a very important aspect of HCI in that, right? So if AI has its limitations, how do how do you how do you provide that output to the customer so that it creates value, right? So if I provide it for this, if let's say someone's asking a question and I position what AI is generated as an answer, and that answer is wrong, or quite wrong. That's one problem with AI, that it becomes quite wrong at times. It's not like humans where it will be a small error, right? And they might just think this is foolish. But if you're not posing it as an answer, but as a recommendation, that kind of problem starts getting solved a little. And there's a very small toy example to understand how, how you presented and the UI, UX and AI kind of talk to each other. But going back to, stepping back, the idea is that when you're starting to scope it and build it, that's the time we talk to the product leaders, the business leaders, do this iterative thing with them. Then we go and sit in a corner and we do the models, because now we have, got the sign off and, we are on the same page on what we're doing. And then we do the models and we sit in our corner, we collect the data, which is a whole topic in itself, right? Collecting data, getting good labels, building trustworthy models and so on. So we sit on the side. And then when we have something which is again demonstrable and integrable in the product, and when we have a prototype, we don't need to do it the full, and then we go back into the product and technology, working with the product and technology teams to start instantiating it there. And then again, iterating with them, because we may also learn some things during the modeling cycle on what is possible and what is not possible, which we thought differently before. So I think it's this to and fro which needs to happen between the AI team and the product team. And I think for us, it's like we need to do it in the beginning, then we need to sit aside and then come back and do that iteration again.
Yeah, great. That's really helpful. And I was just thinking about normally when I'm talking to people on this topic, we talk about, well, what are the biggest challenges that you have? Data comes up pretty much standardly as almost the number one, after are you solving the right problem. So we've got number one kind of covered for a little bit there. I'm sure we can come back and discuss it a bit more. Let's talk about data a little bit more, because you almost can't do anything without data and the strategy. So Jonathan, I wonder if you could kind of give us a little bit of insight, because I know you've been doing a lot of work of kind of laying the foundational aspects into your organizations in preparation for some amazing potential projects with AI. So
yeah, I think there are a couple of things. The first is you need to go play detective. And to sort of Varun's point, playing detective is a great way to figure out what problem am I trying to solve. When you start going in and you say, with a sort of a very open mind, what data assets do I have? So I'm looking at all of the things that I have, and what do I have that are data, and then how sort of, okay, now that I know these things, what could I do with it? Are there business opportunities that I could do with this data, right? So I'm sitting, for example, I got to Fortune and I found out that I'm sitting on thousands of hours of executive interviews with the Fortune 500 CEOs going back 20 years. Thousands of hours of this executive insight. Now, I say to myself, Jonathan, that's probably valuable. Right. And so that's that first start, is you're like, because so much of the conversation, and I think everybody's going to laugh right now, because the current business climate is logs plus magic pixie fairy dust of AI equals profit. Right. And it's a little different than that, right? You're just not going to log file your way out of that. So after you've played detective, you then have to say, what transactions do I have? What data points are entering and exiting my organization? And either going unapologetic and storing everything, right? I was lucky enough to talk to a UK company years ago, ShopDirect, who they had what they called an unapologetic data strategy, where they would store anything and everything they can, and then they would figure it out later. Now, if you've got the money, that's probably a pretty good way to go, some liability concerns aside for sitting on stuff that might be problematic. But then looking at, as I operate my business, here are all of the things, and then start building those storage strategies and storing stuff as quickly and accessibly as you can internally, so that you're sitting on this large repository of data. Because you've looked at the assets you have, you looked at the transaction materials that are coming through, you've started storing them. Now that you have the assets, you have them cataloged, you have them available, that's when you can start ideating through what are the business problems that I'm trying to solve, and do my data assets lend to solving them? And then is an AI application appropriate to utilize for that outcome? And that's like, for me, those are the steps for how you really sort of try and approach that.
Yeah, I think that's really useful insight. Felix, would you add anything to this topic on data?
I guess my main well, I've got two things I'd like to add. First of all, I agree with Varun that when I was trained as a systems engineer, a number of these techniques that we are now calling machine learning appeared on a course that was called optimization. You know, a lot of the sort of gradient descents and what have you, I thought were optimization. So the ideas have been around for a while. You know, these aren't, they didn't just pop out of nowhere in 2010. My second, I guess, concern rather than point was really to do with cybersecurity regarding data, because people are looking at data and worrying about GDPR and privacy issues and what have you. So I have two concerns in that area, one of which is to do with swarm intelligence, which we haven't really got to the point of worrying about. But prior to that is the adversarial examples that Ian Goodfellow talks about, which comes out of GANs, you know, the generative adversarial networks, which pretty much, if you have a machine learning software on your system, you're vulnerable to one of these attacks, because it can, one of the features that it has the ability to do is poison your clean data. Now, when you're storing 100 gigabytes of data, discovering which pieces have been poisoned is quite a challenge in itself. So there are unique challenges to machine learning and the reliance on data, etc., that I'm not so sure are there with regard to conventional software. You know, if you're building cloud architecture, then you're looking at classical cybersecurity solutions, which don't have these kinds of vulnerabilities.
Okay, I mean, I think that's an interesting topic, and maybe we can touch on more of that later, because I love this idea. Well, I hate this idea that, you know, you're building a data set and someone's just kind of poisoning the well. Maybe you can teach us how to stop that, Felix, at some point. I'll let you think about it, though. Oh, okay. You probably already have an answer. Varun, how about yourself in terms of data strategy, labeling, classification? Any advice you would give people?
Sure. You know, I'll just bust a few myths about it. You know, one, you know, people think if they have a lot of data, they can just magically apply AI on it, and that is the value of it is billions of dollars. That's really not true, right? I mean, you really need to know what use case you're using the data for. And, you know, for most AI algorithms, you need to label the data in some way, right? I mean, and to explain it simply is that, you know, if you want to do understand what is there in an image, you first need to have humans say what the image is, and the machine will learn on it. Of course, there are unsupervised ways as well, but you definitely need some supervisory data, which is out there. So having a lot of data doesn't mean it's worth billions of dollars. That's the first thing. Second, you spend a lot of time just cleaning that data, labeling that data, and making it, you know, useful to do any machine learning, right? Like, most of the, I mean, I've really seen people who have done like machine learning in AI and it's totally garbage in, garbage out, because their data is garbage and what comes out of it is also garbage. And because they've, you know, some people just look at, you know, are not trained well, and they'll just look at the accuracy figure and say, oh, we got an accuracy. And when you just try to kind of unbundle it, you know, it's not working. Like, I was talking to a professor in a university, and he said that you know, they were working on a question answer data set, and the accuracy was quite a bit improved by their algorithm by changing the network a little. So they said, let's look under the hood. And somehow they found out that for that data set, the way it was laid out for a large number of questions, the second last word in the question was the answer itself. And that was happening for a large number of points. And that's all the machine was doing, So data is not money. You have to spend a lot of time cleaning that data and getting good labels. And the third uh, myth I would want to bust is that for all applications of machine learning and AI, it is not the case that you need billions of data points. You can do a lot of machine learning only with 500 data points, 1,000 data points, 10,000 data points, and so on. And as the field is progressing ahead, we now have a lot of pre-trained models which can be easily adapted with a few number of data points as well. In fact, if you look at a lot of problems which are solved in the industry, where you'll get the bang for the buck would be based on small data sets, because you would never spend those all dollars to like label millions of data points, right? You would only do it for very broad applications, like if you're trying to do speech recognition or solve object classification, which is a service you can sell to a lot of customers. But generally, it would not generate you the kind of revenue to put that kind of an investment. And what you need to know as business leaders is that you can start using AI and even have data sets as big as 1,000 data points, and it can start generating value for your business.
Yeah, it is interesting how things like GPT-3 and the news around how much data has been passed through that in order to train it so it can create, novel textual things. Or I remember when IBM Watson was being pitted against doctors for diagnosis, and they kept talking about how much data had been passed through it, and this is the reason why it was doing so well. So it's quite interesting that you're saying, actually, that's not always the case now. There are some use cases where you do need that, but there are many pieces where you actually don't. So it's quite fascinating. One of the things that struck me when we spoke, Varun, was about the humanity of what you're doing in particular. So you were talking about one of the challenges that you saw, which was about actually making decisions that impacted humans and how you thought about that. Would you just share a little on that for us?
Sure. So this topic has got a lot of visibility now, which is about the ethics of AI algorithms, right? And when you should use it and how they should be built on to be ethical. And it's interesting, the field I come from, which is assessments, we have thought about this topic for quite long. In fact, in the US, there are laws around what you can use and what you cannot use, because it's a very sensitive area where you are making decisions on humans. What your test gives as a result might determine someone's employment or not, his or her economic status, his or her lifestyle, etc. Something which will be even more sensitive than that would be healthcare. If you're making healthcare decisions, an AI algorithm is making healthcare decisions, and you diagnose someone wrongly, that could have a very, very high cost, which may not be, when we cannot even put it in numbers, right? So, and what says, and generally, this is how I give an example. Whereas if you're using an AI algorithm to predict a stock price, you may not worry so much about the ethics of it. You may definitely worry about the financial impact which you might have if the algorithm doesn't work well, but not the ethics of it. And so, when you are working in a field like ours, we need to do a lot of work to see, the stakes are fairly high, as I said, to see that the algorithm is working right, it is working fairly. Does it work well both for males and females, for examples, or people of different races? And that's where you need, uh, many times when you have these AI teams, they don't have good statistics background or statistics capabilities. And that is, so what has happened in the field of AI is that if you look at the algorithms, they have been fairly commoditized. Then you can pick them up from the web, as Jonathan was saying, it's a lot of it is out there and you can use it. But do you know how to use it right? And do you know that when you use it and you build these models, how to test these models and say that they are working? That's where you need a very deep statistical understanding. And unfortunately, what has happened, what is true for the whole world, is that there are very few people who know both computer science and statistics, right? And maybe Felix is one of them, but there are very, very few such people, right? Which kind of creates this, creates this big challenge that you have a team which is creating this algorithms, but they don't really know how to test them and say that, the example which was being given again for Google, and they went onto the field and the algorithm did not work. And so that thing is still a challenge in AI, that a lot of algorithms are brittle and people don't know how to test it well. I'll give an analogy which was given by this researcher at Berkeley, who's a father figure in AI. His name is also Michael Jordan, and he gives this example where he says that if you look at civil engineering, uh, there is a, a set of rules on how you should build a bridge. And if you don't follow those rules and do those tests on a bridge, that bridge will fall. But do we have that for AI algorithms? Do we know that what are the steps and rules to build an AI algorithm and how to test it so that it will not, it will not break? And for what circumstances will it break, and what circumstances it will not break? And with the hype of AI working well in the lab, industry has come very fast lapped it, but they have not. They really, that science of making sure that the algorithms are robust and how to do it is still evolving. It is coming out as some global standards which are coming, which one can follow. But I think that will take a few more years to get it, you know, get it totally standardized, and people know that when they will work or not work. And when we are making decisions on humans, this becomes like 100 times more important. So in my team, we need to do it very, very carefully, plus also have cross domain knowledge, right? So we need to not only understand how AI works, but we also need to understand that something about psychometrics, something about human psychology, something about the science of assessments, and make sure whatever AI models is saying is theoretically plausible. Otherwise, we run grave risks on what we are doing.
So we had a question in a Q&A from Ian, which was, if you have a machine learning tool to do something, how do you know what it has learned and so trust what it does? And I think you're touching upon some of those aspects there, Farhan. I like Felix, how would you answer Ian's question?
Tread very carefully.
Okay.
And as Varun was saying, one of the issues that we're really facing with machine learning is that we've got to the point where we can build these things. But how do we trust that the machine has learned what we hope it's learned is a problem we've faced in education for a very long time. I mean, you can teach, algebra, and the students can respond to the tests that you set. That doesn't mean they've learned algebra. That's a problem we've not been able to crack in education. And I think we're beginning to sort of see that in machine learning, in particular, because a lot of the models are fragile. And by fragile, I mean, just sort of going back to this notion of adversarial examples, Ian Goodfellow was able to add some noise, and some noise, I mean, less than 1% of noise, to an image that was clearly a panda. And the result was clearly a panda to any human being. But for the machine learning, it went from saying it's 60% a panda to 93% certain it was a gibbon. And these are really sophisticated machine learning examples that he was using. I mean, we're not talking about something that was created in a classroom from an inexperienced person. So we're learning an awful lot about how these algorithms with the data, their behavior. So can we trust them? The answer is sometimes. And we don't really have the science to decide which ones can we trust and which ones we can't.
Yeah. I mean, so like some practical applications that I've seen over the years, like, you train a model and you get more and more data and you get more and more understanding. Like, what's the point where you retrain a model? When does that happen? How do you know it needs retraining? Why would you retrain it? And all of those good things. Like, it feels like the amount of information about training a model is there's a lot out there. But then what you do after that, it seems to be a really weak area of expertise.
I think Tesla. Go on. Yeah, I think Tesla is a good place to look.
Yeah.
With Andrej Karpathy, because he essentially collects data from all of their machines, all of the vehicles that are out on the road, generate data, and that they're continually collecting that data, and that there is an arbitrary point where they have enough that they believe warrants a new model. The model is built in a data center, by the way. It's not built in the cars themselves.
Yeah.
So they collect all of the data, they build a new model, and then they deploy it back to the vehicles. But I think there is no. It's not like classical software. We really don't have an answer of when do you retrain a model. I think that the best we can do is when you begin to see that there is an unacceptable number of errors from the model that you have. You realize that you need a better, but you have to continually collect data. That's the other thing.
Yeah.
It's not a one-shot thing where you build a model, you deploy it, and you're good to go.
Yeah. Yeah, no, it's a really interesting one. And actually, Paul was talking about how data quality is fundamental and common sense is what he says in the chat window. But he's interested in actually understanding tools that might be help you get some control or understanding of the quality and the availability of the data. Have you guys got any advice to someone who's looking at tooling in this space? Jonathan, maybe?
I don't. Data quality isn't something I'm having to sort of tackle right now. It's it's absolutely a huge problem. I mean, sort of, Varun mentioned this, and I'll just sort of opine really quickly. One of the things that every C-suite needs to be told is that 80% of a data scientist's time is spent on cleaning the data. Now, you think about what a data scientist makes, and you think about the cost of that. And so Paul's question starts to become a really, really good one, because that's a very, very expensive problem that we need to solve. I'm just not the guy to answer it.
Okay, Felix, any ideas?
There are some techniques that are not as dependent on data as others.
Right.
The human in the loop, where you're not planning on completely replacing a human being with one of these automated systems, I think is a good solution, because humans are still very good at spotting anomalies. So if you're looking at augmenting the capabilities of human beings rather than automating them, I think you're on solid ground. There are tools coming out of IBM. Grady Booch is leading quite a sort of tour de force in trying to bring the world of software engineering to some of these machine learning and AI techniques.
Right.
And I think he's doing some good work. And Michael Jordan, that Varun mentioned, is also working on that. There are some people out of the Scandinavian countries, again, focused on bringing real software engineering techniques. It's a developing field. I mean, it's in its nascency. It's not. So I tend to sort of, whenever I'm faced with a greenfield, is to use techniques like design thinking, SWOT analysis, what have you, to really just boot this thing up.
Right.
And if you're in a regulator, a business sector that involves regulators, then, they want transparency, they want explainability. The tools are just not there to sort of support those kinds of compliancy issues.
Yeah, I mean, I've seen that one come up a lot with business leaders questioning technology leaders and saying, great, good that we've done this piece of deep learning and we've built a model on such and such. What is it doing? And it's a black box, and nobody knows what it's doing. I mean, we can see what goes in and we can see what comes out, but actually what gets processed in between is not always clear. And especially with these models they're there, you just take them off the shelf. I mean, they literally are black boxes. And I think this area, so Paul's question was, what is the availability of the tools? So what I think we're agreeing is not that available.
Right.
Aaron, would you argue that at all, or would you agree that also there's the availability of the tools that help us do this are very low?
Yeah, I think it's still evolving and coming up. So it will take a few years when we have, some standards emerging in the market.
Exactly. Sounds like a huge opportunity for any entrepreneur on the call.
Yeah.
And so this is an evolving field, and I think that's a really really interesting.
Point. Sorry, Phil. Could I just make one other comment?
Mm-hmm.
People talk about these neural nets as if they're, we've modeled the human brain. That's the hype that I spend most of my time trying to break. If you go back to its roots and sort of say, what is the model doing? It's fitting a curve to the data you've given it. So asking it to explain, imagine that you're basically, I mean, it's non-parametric data fitting. Mm-hmm. Coming from statistics. So asking the algorithm, what are you doing? This is the best curve that I could fit.
It's the line of best fit. I mean, it's
right.
literally gradient descent. Like, I decided this is the right line.
That's right. It's the one that minimized errors.
Yeah.
But there are better techniques. I mean, one of the techniques that Ian Goodfellow talks about is the use of game theoretic. Right. So, you have two neural networks, and they're basically using game theory to determine what is the best strategy. Now, that's real scary stuff. I mean, I don't understand why people are not scared by this. Maybe they don't care. I don't know. But moving from gradient descent to game theory is a huge leap. And really, some of the reinforcement learning examples that you see for, the two football players that one morning didn't know what football was by the afternoon, they were playing a soccer game.
Yeah.
That uses sort of reinforcement learning coupled with game theoretic underpinnings.
Are you talking like a Nash equilibrium or something like that? Okay.
Yeah.
Okay. I mean, it is a fascinating field for sure. And the understandability for the lay person, and I don't mean the lay computer scientist, the lay statistician, is really quite, there's a big gap between a brilliant business person and their understanding of statistics and maths and the things that are actually going on here. And that's no slight on anyone. It's just the reality is there is a big gap growing in terms of understandability in this field. So that you're saying, why are they not more scared, or why are we not more scared? I don't.
Well, it's not the business people. It's the technical people that worry me. I mean, I had a discussion recently with quite a senior person, and he said, well, it's unusual for somebody who doesn't claim to be an expert in the field of machine learning to have an understanding of adversarial examples and adversarial learning techniques. So, it's not just battling the hype with regard to people who are business people. I mean, that's just fair in my mind. I mean, why would they have the technical know-how of how this stuff works? But sometimes it's facing people that are in roles, in positions of in executive positions, where it's not necessarily just inexperience of machine learning techniques, but inexperience of just distributed systems in general.
I think this is where we kind of stray into kind of what there's lots of different classes of things we're talking about. We had one question a moment ago, which is AI just automation? And maybe we could talk about that. But in some cases, it is literally just a chatbot on your website or a chatbot in a product. And the ethical challenges of that may be quite different to when we actually have a question in Q&A about lethal autonomous weapons, which we'll get onto in a second. That sounds like a much bigger issue than the chatbot. But let's talk a little bit about the ethical implications for your your business. And, you know, Jonathan, you mentioned something to me when we chatted around kind of advertising models and that piece of actually, you know, some of the things that were covered in things like the social dilemma and the attention and all of that. Do you want to give us a little bit of your thoughts?
Yeah, I think there are times where if you ask me, I would flip back and forth between what's the one technology that I would get rid of. Half the time I would sell the smartphone because I think they're sort of destroying human beings. And the second is social media and sort of very specifically the algorithms that power it. You know, there is zero ethical standing for almost all of these algorithms, and advertising and personalization. All of these things are just, it's sort of ethically bankrupt. I would probably say morally bankrupt, because then you're sort of using sort of value-based judgments as opposed to reason. But I think we could argue either without getting, you know, nuts. Their only purpose is to get you to consume more. And I want you to think about that for a second. And I, like, running a media business, I struggle with this because, you know, I want to make more money, which means getting people to read more articles so that I can serve more advertising. And that's a horrible, horrible position to be in, because you're giving them more of what they want, right? You're not giving them more of what they need. You're giving them more of what they want. And that's just an awful situation to be in. And right, so I'll use sort of personalization as an example, where if I read 3 articles about Facebook, I'm going to get a 4th article about Facebook. But I'm not reading the article because I care about Facebook. I'm reading the article to learn about privacy. And the algorithms don't know that, or they don't care, right? Because the model, as we've pointed out, knows that if I get a 4th article about Facebook, I'm more likely to click on it than I am about an obscure article about GDPR that's really dry, that I need to know because I need to understand that. And so you see that in content recommendation. You see that perpetrated through social media apps. It's, you know, Felix, you talk about data poisoning models. Like, social media is a giant data poisoning model, because one piece of information that goes in that is wrong or disruptive, even if it's shared in sarcasm, gains legs and becomes bigger and bigger, and then goes and then destroys the whole model. And so there's not a lot of work on this, right? You know, the advertising systems are being honed to a razor's edge to know what we want, to get it to us. And it's, you know, I as a human being have no value in that equation. I am merely something that is going to consume the result of it. And so, you know, some pretty horrible advances in technology are being done in the name of business. And I think that's probably just as scary as autonomous weapons.
Well, so Varun, what would you add to this about kind of your own industry and any ethical thoughts on it? I know you touched upon that human decision making previously. Would you add anything else?
Yeah, I'll just couple of comments, you know, but the whole book, The Bird Farm, is about, you know, the impact of technology on society, right? And the 2 things which Jonathan spoke about, the mobile phone and social media, talks a lot about that, right? And I think the few things to understand is, one, that technology is moving so fast. You're talking about business leaders not being able to understand it. Think about the government and think about the policymakers. They have no clue what's going on, right? They've been always distant from technology, and now it's growing at such a rapid pace that no one has any clue. And you know, it works both ways. They can make policies which can totally destroy technology. So they really don't know what is the way to manage some of these technologies to make sure that they're used ethically and for the benefit of the society. And the other thing which is stated, you know, it's a very, very simple thing, but people generally miss the point. And there's this a person, good friend, Kentaro Toyama at University of Michigan, who wrote this book called, forgetting the name of the book, it was Geek something. But the whole idea of the book with what he says is that technology just amplifies things. That's what technology does. But finally, it's humans who are using technology in one way or the other. It can amplify greed. It can amplify consumption. It can amplify anything, right? It's just this huge replicating force. But how it is being used is still in hands of humans, organizations, and policymakers. And though this is like stated it sounds very simple, but it's not very clear. People think that, oh, technology would automatically solve problems and automatically do things. So that's one perspective. If you look at our business and what we are in, which is assessing people and assessing people for jobs, the rightful use of technology, that's an extremely important question for us. And a lot of discussions today go within the business to how to make sure that, for example, our assessments are not racially biased. There's sometimes simple things which we know that could diminish the bias you can have with tools like this. And let me again give you a very simple example. Scientific studies show that if you're doing these tests between blacks and whites, the score difference is high. But if you just simply give them a demo test before the real test happens, that difference kind of goes down. So if you're being careful, you can do these very simple things which makes some of these technologies less biased towards certain groups. And that is, as a business, we need to think very, very carefully about it, because again, our mission also is to get the right person in the right job. And if we're not doing that, the very principle of the business gets defeated.
So I've got three kind of morally things, and we don't necessarily want to spend a lot of time, but I do think it's an important important topic. So Felix, I'm gonna throw three moral stories at you. So the first is, who will a driverless car sacrifice in an accident? And so just talk us to a little bit more about how they might train. So let's start with that one, and I'm going to then read out what someone has written, because I don't want to get it wrong. So if you start with that one, autonomous driving vehicles and making choice.
We're trying to ask a machine to do something that we don't know how to resolve ourselves.
Yeah.
So I think that's throw a die for all I care. I mean, I'm not being callous, but how does a human being decide? It's random. It's a spot decision on the moment. They decide to, make one decision or another. They don't know why they did.
And this moral dilemma has been around for many hundreds of years. And this is the classic moral dilemma. Okay, so can I just
go on? We have a lot of technology, because AI doesn't exist in a vacuum. We have a lot of technology that is very useful, that saves lives, that is a truly positive value to add to human society. And we're stuck on philosophical problems that are conundrums, paradoxes that we have no way of resolving. And to sort of bring AI down and say, well, we're not going to deploy it until we can solve this problem, I think is is really sad, because we can benefit from the good.
Exactly. So here's the one I'm going to read out. Again, I just don't want to get it wrong. So there are already many semi-autonomous lethal weapons in use today that rely on AI-based autonomy for certain parts of their system, but have a communication link to a human that will approve or make decisions. There is a global aspiration to develop lethal autonomous weapons that systems that can identify, select, and engage a target without meaningful human control. Given the panel's comments so far on the limits of AI, is this a realistic aspiration? Should we be concerned about such an aspiration? Now, obviously, this is straying into military and war applications, and we don't necessarily need to get into the good, but should we be concerned about such an aspiration? Feels like an easy question.
Should be.
We should be concerned.
I'm not so sure. Full disclosure, I'm a former Marine.
Okay.
So, I have thoughts.
This is why we have diverse audiences, Jonathan. So let's go.
Yeah. I mean, look, so you're actually talking about what I consider one of the easier problems to solve in AI, which is computer vision. So knowing what a thing is, and right, and Felix made a great point about noise in that, and you know how that changed the assessment. But you're talking about computer vision, recognizing an object, and then looking at a threat matrix for how dangerous that object is, and then conditions for whether or not you should engage said object. I think you can do sets of rule systems that have clear rules for engagement.
Yeah.
And again, you default to a place of safety, which says you do not do this if enough criteria aren't met. But you know, I firmly believe weapons have become so dangerous, and the U.S. military talks about this, that war needs to be fought at a distance. And so the more distance that you can provide, and the faster that you can make these decisions about what is a threat and what isn't, is going to save people's lives. And so I think there are some control mechanisms, but I do think there are weapon applications there that should be explored.
Just as long as it's not pandas versus gibbons, is what
Right.
Thanks for that. And just to finalize the ethical moral piece, George has asked, is online gambling an example of an industry with heavy AI use where direct harms can be seen in general peaceful society feeding damaging behaviors? So similar to kind of that social dilemma that we were describing, you know, is gambling another example of that?
That's a tricky one. I mean, you know, humans were gambling long before we got them, you know.
So I think
to
the
use
conclusion
AI.
that I'm coming from this piece is actually we've got some really human issues that we still have not resolved. And Varun's point about amplification is really key here. So we can just do these at more volume. We can impact more people's lives. And actually, as technology leaders, as business leaders, we do have an obligation to consider the ramifications and the impacts that we have. You know, with great power comes great responsibility. I think what we're agreeing is that AI has great power, and therefore we have to take great responsibility.
I think. Sorry, go ahead, Varun.
No, I was just going to say, you know, Phil, I think one of the things which we need is that we need more technology people to talk to more social science people, and more of that happening at more formative years, which is not happening, right? And that conversation, because this is a conversation, and humankind has given different answers to the same question at different points of time. It's an evolving question. But what we really, I think the big rift is that we don't have the sciences and the social sciences talking between themselves, and the need today is more than it has been ever before.
And I think it's a great point. And actually, we have one other question here, which I'll just touch on now. And we're going to stray a little away a bit from the moral stuff just for a second and get into kind of ramifications for business leaders and tech leaders, which is what are the skills and expertise we should be looking for, like as an organization starts planning over the medium term, their approach to technology, business, and social sciences, and all of these things. Like, what is it that you would recommend to colleagues as to how they should be hiring and what skills and capabilities they should be searching for?
So I'll opine with a general one, which I think the number one skill that I'm starting to look for across the organization, and it doesn't matter in what, is data fluency, not data science.
Yep.
But really understanding what data is, how it can be applied. I should have said R. My wife will kill me for using a singular instead of pluralizing it properly. But really understanding the difference between leading and trailing indicators, vanity metrics, how data can be applied. Just a good understanding of wanting data to make decisions rather than going with opinion. But I think that needs to organization across.
No, and I agree completely to Jonathan. I think, the simple example is that in the 90s, computer literacy started becoming a horizontal skill. Whatever job you are in, if you would know computers, you'll do better. Data fluency is now becoming a horizontal skill. So even your business leaders, anyone and everyone needs to have data skills. And I will go as far as saying that probably even programming to some extent, right? Even I won't say probably programming, but scripting is kind of becoming a horizontal skill. And companies like GE have done this, that where they've asked all their business leaders to have data fluency, have programming, which is like so different from how they've conventionally worked. But that's the new reality of the world. And one last comment would be that within data science and data engineering, we today have a much better understanding of what are the kind of roles as data engineer one, data engineer two, applied data scientists, and so on, and what skills are required for them. So which this clarity was probably not there 5 years back, but now that clarity has been emerging and people could look at resources for understanding what these roles are and what are the right kind of skill assessments for them. And we also do some of them in our portfolio.
Anything you'd add, Felix?
I agree. I think here's my speculation. Within the next 10 years, I think we're going to see statistics and computer science merge because they naturally belong with one another. And whatever title they decide to call it, will also require more effort into turning it into a software engineering type discipline. So anything that involves software engineering, data science, data engineering, I think is a good thing to go with. Plus, I would add that it's always good to have someone with some experience. Going on a 6-month course and then calling yourself a data scientist can be quite a difficult issue for the manager because you don't really know the capabilities of that person. They have no track record of having built any kind of system at all, and understanding how systems interact. And I guess my main reason for saying that is unintended consequences. Once you've started building some of these larger systems where the components interact with one another, and you sort of you realize that you hadn't even thought about what could come out.
Yeah, I mean, it's quite interesting because obviously we've strayed into morals and ethics and like the impact that some of these things have got. And that idea of just about hiring someone who's got 6 months training experience and then kind of putting them into a really major piece of potential where like getting the data wrong can lead to poor consequences. Training the model incorrectly could, like, even just having a poor idea about and not putting the right checks and balances and validating. So it feels like there needs to be a real level of rigor and robustness that we put around some of these ideas. And the term thoughtful, like a thoughtful approach, like seems to be one that needs to be considered.
Well, I mean, do you remember the Boeing, was it 777 or was it the 787 where the batteries were catching fire, and it turned out because it was an integer overflow. So we're still struggling to have a decent software engineering discipline, and we're we're sort of steering into the unknown with these sort of data-driven models.
Yeah.
So.
Yeah, exactly. So I've got a couple other questions that one that I don't understand. So I'm going to put it out there and then you can let me know if you understand it as well. And so it says, what is the difference between weak AI and strong AI? Any ideas?
I mean, go ahead, Felix.
No, it's okay.
No, I don't. I mean, so I've not heard weak AI and strong AI, but weak algorithms and strong algorithms, the way we would understand is that weak algorithms are something which, which work for a wide variety of problems. but may not solve any of them very, very well. And strong algorithms are which would work for one or two problems and solve them very, very well. Now, if you bring this to AI, what we know today is, and I'm sure Felix can speak a lot more on this, but I'll just give it a beginning, is that the AI which we have today, which works for very narrow problems. So it's a very narrow task like classifying images. We can have very good, strong, maybe that's why he's calling it strong AI, to solve that problem with very high accuracy. But as soon as those tasks become broad or multi-step, which humans generally do, AI is not able to handle those tasks as what is the state of art today, right? And within AI, they call it artificial general intelligence, AGI, and saying that AGI is not solved. That is tasks which are broad, multi-step. Like, when people talk about robotics, right, and dancing robots, right? I mean, one thing which is in the last 10 to 15 years, robots have made a lot of progress, but they cannot still do very simple things, right? Like 10 years back, they could not pick an object. Today, they can probably pick an object, but can they pack an object which they don't know about earlier in advance that what that object is? They still cannot do it, which humans do seamlessly. So very easily AI breaks, when you have these tasks which are more broad and more general, and probably that's what the person is alluding to. But again, if you'll go back to the academics and when the AI term was first coined, that's when what they meant when they were coining AI, that they would be able to do these general complex tasks.
Right. Excellent. Well, so I didn't even understand the question, so I appreciate the attempt at an answer. We have about 8 minutes left, so I thought maybe just a final thought from each of you around just kind of what would be some key recommendations to business leaders or technology leaders who are more likely to be on this call at the moment. What would your advice be? And maybe Felix, you could lead the way here.
There's an awful lot of good things that machine learning and AI have brought to the table. And I think it's important to use them for the, if you like, AI for good. And some of them, sort of piggybacking on the comment that Jonathan made earlier about autonomous weapons, people sort of say, well, you're automating jobs. I watched a video of a human being packing pencils into a box, 8 hours a day. That's a soul-destroying job. Reading addresses on an envelope and typing them. So automating some of these jobs, in my opinion, is a good thing, as long as we hold ourselves responsible to then provide them with a career path, away from that position. So, give them something else to do, retrain them, what have you. Just to throw them out into the street, I think is unethical. But, if you look at the example of X-ray systems, those systems can see phenomena that humans cannot. Much like we couldn't see much of the universe without a telescope. We couldn't see much of the nature without a microscope. I think for me, that's where AI is at the moment. It's providing a really useful instrument. And, I would like to end on a positive note and say, these technologies exist as long as you don't push them to the edge. I think they're very useful.
I think that's a really good, it's a really good rallying cry, actually, Felix. Like, there is so much opportunity. The amount of compute power we have today, the amount of things that we can do now is phenomenal. And it is good to seek the good as well as talk about the morally challenging as well. Thank you. Jonathan, what would you add?
Yeah, it's interesting. What I would add is that even if you're talking about AI products and doing something with AI, you're still building a product. So don't start with the AI. Keep focused on the 3 criteria that all good products have, right? They are usable, useful, and desirable, right? They have to be usable. Somebody has to be able to use the tool. They have to be able to get what they need out of it. It has to be useful. It has to do something of value. Mm-hmm. And then it has to be desirable. There has to be a reason you want to do it or that you want to use it. And AI is a tool like any. And if your product doesn't meet those 3 criteria, just because you have used the latest buzzwordy thing and maybe get a raise for it, your product is still going to fail if you don't make those 3 criteria.
It's a good reminder. And Varun, how would you end this talk then?
So firstly, I'll endorse Jonathan's point. I think that is the single one most important thing which, business leaders and technology leaders should engage themselves in is what is the product being created using AI, and be part of those discussions and make sure value is being created for the customer and understand what value is being created for the customer. And I just would want to add, what we have already said, but as concluding remarks, like walking the talk, I think if our attendees should also get the data fluency skill, and really encourage people who are both in technology and business to learn some of these skills. There's a lot of hype, but if you scratch the surface, it's not very hard to understand at a big picture what AI can do, can't do, and what are the use cases. And rather than living in the bubble of this hype and what media is pouring on all of us, including robots, which become citizens of countries, which really, at least to me, makes no sense. They can scratch the surface and understand what is really going on. They don't need to understand all the techniques, but they need to understand the big picture. And what I would lean on the attendees here is that get that understanding themselves, and in fact, to their technology and business leadership skills. There's plenty very short courses out there which people can take online, and and some of them are built for executives because of the amount of misinformation which is out there. Because if you really want to build AI products, you need to understand it in the big picture as a team, and you cannot just have an AI team sitting in the corner and doing some magic, and that would not work.
And I'm sure SHL and the Aspiring Minds team, Varun, are already looking to figure out how to sift and find these types of characters for the workplace, right? So
sure. We can, that's also a very interesting question. There is what a lot of companies ask is that we do have tools for finding data scientists and data engineers, assessing them. But what companies are looking for, which is very interesting, is that who has the potential to become a data scientist or data engineer? Because a lot of companies are training a lot of people now on these skills, and they want to know that what subset of their current people should they pick up and train in these skills. And that becomes like a more interesting problem on assessing people for that potential to pick up these new technologies.
And it's a good point. I mean, obviously, so like the company I'm representing, Altamira AI, they spend a lot of time thinking about developing the skills, training people internally, trying to create, take computer scientists out of university, but delivering the, the data fluency, the data insights, the statistics, the maths, and all of that stuff that has to go with it in order to create great products. And I think we'll see much more of this over the coming years. So on that note, we have 1 minute left, so I'm going to hand it back to Phil. I really appreciate the conversation, guys. Really enjoy your expertise and your insights and your clear wisdom on this topic. And thank you so much.
I'd just like to echo that. Thank you, everyone, for taking part. Thank you, everyone, for your questions. A particular huge thank you to you, the panelists, and Phil for being a superb host once again. The conversation doesn't stop there. Please contact us via Technofresh. Seek us out on LinkedIn. I want people to become part of the collective so we can keep these conversations going over and over again. Our plan is to do a number of these throughout this year, and we're really keen to get as many people involved as we can to become expert panelists. Just reach out to us. And of course, the one thing I'll take away immediately is we'll get our team looking for data fluency skills, so TalentSmart can become #1 supplier of that skill going forward. So thank you for that. That's a heads up for the future recruitment trend, which is always brilliant. But thanks to everyone for giving the time. It's been a marvelous event, and I look forward to the next one. Thank you so much. Cheers.
Thank
Bye.
you.
Thank you.
Bye.